Okay, so look, in previous class I have told you what is the classical definition of probability, or what is the definition of probability. Okay, I am just remind you once again what is the definition of probability. Okay, so the definition is, let S is the sample space and A is an event of that sample space. The set is, the sample space is contain n of S element, and the set A contain n of A element. Then from classical definition of probability, we can say that probability of A is equal to n of A by n of S. Means the number of element are favorable for the event A divided by total number of element. This was the classical definition of probability. Clear? Now we'll going to solve few problem using these definitions. Okay, so before going to the problem, we have a few MCQ type question here. So let's solve the MCQ questions. So the first question is, okay, I'm going to read the questions, you will give me the answer. The first question is, the probability of a event E plus probability of a event not E, means probability of E plus probability of not E is equal to what? What is the value of probability of? Very good. So sum of the probability of an event that to be happened and not to be happened is always is equal to 1. Very good. First question. Second question is, the probability of a event that cannot happen, the probability of event that cannot happen is 0. Very good, it is 0, and the event is called, one has given the answer, yes, the probability of event that cannot be happened is 0, obviously. And what we call the event? Yeah, very good, we call the event as impossible event. We call it impossible event. Okay, go to the next question. The next question is, the sum of the probabilities of all elementary event of an experiment is equal to what? Is equal to, okay, 1. Is equal to 1. Okay, I'd like to explain this question, why the sum of the probability of all element is equal to 1. Okay, so I'm just giving you a situation. Suppose you have a die, you throw the die. Okay, so what are the sample space, what are the possible outcome in case of throwing of a die? We know that it is 1, 2, 3, 4, 5 and 6. This is the possible outcome of the experiment. Okay, so here the total number of element in the set is equal to 6, obviously, because the 1, 2, 3, 4, 5, 6 element. Now my question is, what is the probability of 1? So there is only 1 out of 6, so 1 by 6 is the probability of 1. Similarly, if I calculate probability of 2, so it will be also 1 by 6. Probability of 3, it will also be 1 by 6. Probability of 4, this is also 1 by 6. Probability of 5, it is also 1 by 6. And probability of 6, it's 1 by 6. Now if I add all the probabilities of the element, then we have probability of 1 plus probability of 2 plus probability of 3 plus P of 4 plus P of 5 plus P of 6. Okay, so as you can see that the value of the probabilities is always 1 by 6. Okay, so 1 by 6 plus 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 1 by 6. So if I add the numbers, so it will be 6 by 6, that is equal to 1. That is equal to 1. That means the sum of the probabilities of the all elementary event is always equal to 1. Okay, Okay, Shubhajyoti. Okay, now next question. The next question is the probability of a event greater than or equal to what and less than equal to what? Okay, it is greater than or equal to, very good Srijan, it is greater than or equal to 0, not Ishanu, it's not 1. The probability of a event is always greater than or equal to 0, but less than or equal to 1. It is greater equal to 0 means 0 less equal to a probability of event less equal to 1. Its value must be lie between 0 and 1. Okay, so the answer is the probability of a event is always greater than or equal to 0, but less than or equal to 1. Clear? Okay, now let's go to the next question. Okay, I'm skipping question number 2. I'm going to question number 3. Okay, why tossing a coin considered to be a fair way of deciding which team should get a ball at the beginning of the football game? Can you explain me why? Who can explain me why is tossing of a coin considered to be fair way of deciding which team should get the ball at the beginning of the football game? Anyone would like to answer the question? And then I will give the answer. Quickly. As both have equal chances to get head and tail, that is 0.5, 0.5. Yes, very good. Because look, we know that when we toss the coin, so two possible outcome may occur. One is head and the other outcome will be tail. Okay, one outcome is head and the other outcome is tail. Now, if we calculate the probability of getting head, so it will be probability of head is equal to 1 by 2. Similarly, probability of tail, it will also be 1 by 2. So probability of getting head or tail is equal, means the events are equally likely events. So to winning the game, winning the toss, have equal chances, 50% for head, 50% for tail. That's why it's called a fair way to deciding which team will begin the match. Clear? Okay, now next question is which of the following cannot be probability of an event? Which of the following cannot be probability of an event? So the first question is 2 by 3. Okay, what is your opinions? That can be probability of event or not? If yes, then tell me the reason why it may be the probability of an event. Or if your answer is no, then you tell me why it is it cannot be the probability of an event. Anyone would like to answer the question? Yes, it is greater than 0. It is greater than 0. Not only greater than 0, Srijan, you have to mention it is also less than 1. Because we know that probability of an event is always greater than 0 but less equal to 1. And this number 2 by 3 is lying between this interval 0 and 1. This value is greater than 0 but less than 1. So that can be a probability of an event. Clear? So the next question is minus 1.5. Okay, so that can be the probability of event? No, because we know that the probability is greater than 0 and less than 1, means it will be a positive number. But here the given number is a negative number, so that cannot be the probability of a event. Clear? Now next is 15%. 15%. Now look, this number is a much more greater than 1. Now you tell me whether 50% can be the probability of a event or not. It's not 50, it is 15%. Okay, it is 15%. That can be the probability of event. Is it possible? Yes, it is possible, because we know that this percentage can be written in the form 15 by 100 to make it a fraction. So 15%, which is equal to 15 by 100. This number is lying between 0 and 1. So 15% can be the probability of a event. The next number is 0.7. The next number is 0.7. Is it a probability of event? 0.7? Obviously 0.7. This number is also lying between a 0 and 1. So this is also the probability of a event. It can be a probability of event. Okay, any questions up to which I have done, up to question number 4? Anyone? Any doubt? No. Okay, so let's move to the next question. Question number 5. Question number 5 says that if probability of E is equal to 0.05, then what is the probability of not E? Now look, it is given that probability of the event E is equal to 0.05. My question is, what is the probability of not E? What is the probability of not E? This is this can be written in the form probability of E naught. Both are the same sign. Both gives the same meanings. You can write E naught E or E and a dash over E. Okay. So now look, we know that the solution. Okay, we know probability of an event to be happened plus probability of event that cannot be happened is always equal to 1. Means sum of E plus sum of E plus and E dot is equal to 1. The value of P of E is given, put it here, which is equal to 0.05 plus probability of not E is equal to 1, which means probability of not E is equal to 1 minus 0.05. Now subtract 0.05 from 1. Yes, the answer will be 0.95. So probability of not E is equal to 0.05. Okay, similarly I am giving another questions. Suppose probability of not E is equal to 2 by 3. So what is the probability of E? Tell me the answer. Probability of not E is equal to 2 by 3. Then what is the probability of E? We'll apply the same procedure, same formula, and tell me the answer. Yes, very good, Isanur. It is 1 by 3. Because we know that probability of E plus probability of not E is equal to 1, which means probability of E plus the value of probability of not E is given 2 by 3 is equal to 1, means probability of E is equal to 1 minus 2 by 3, which is equal to 1 by 3. So 1 by 3 is the answer. Okay. Now the next question is question number 7. I'm skipping question number 6. You just have a look on the question. Have a look at the question. Question number 7 is, it is given that in a group of 3 students, the probability of 2 students not having the same birthday is equal to 0.992. What is the probability that 2 students have the same birthday? In a given group of 3 students, probability of two students not having the same birthday is equal to 0.992. Then what is the probability that 2 students have the same birthday? Yes. Okay. So look, it is given that total number of students, no need to write this one, it's irrelevant. Look, it is given that probability of 2 students have same birthday is equal to 0.992. Okay, then probability of 2 students have not same birthday is equal to 1 minus 0.992, and just subtract this number 0.992 from 1. So it will be 800, so 0.008, 0.008, yes, 0.008. Okay, now next question is question number 8. Okay, question number 8 is, a bag contains 3 red balls, 5 black balls. A ball is drawn at random from the bag. What is the probability that the ball drawn is red? And the second question is, it's not red. Okay, so here we have a bag and 3 red balls, 3 red balls and 5 black balls are there. 3 red balls and 5 black balls are there. Okay, you put your hand and pick up a ball. You have to find what is the probability that the ball will be red. That was the first question. And the second question is, it is not a red ball. Okay, so how to see how to solve the question. So here given number of red ball is equal to 3 and number of black ball is equal to 5. So what is the total number of ball? Total number of ball that is equal to 3 red ball and 5 black ball. So total number of ball is 3 plus 5, that is equal to 8. Okay, now probability of red balls. So probability of red ball is equal to, now the formula is the favorable number of outcome by total number of outcome. Favorable number of outcome by total number of outcome. Okay, so what is the favorable number of outcome? So here, because there are 3 red balls, so favorable number of outcome is 3 divided by what is the total number of outcome? The total number of outcome is total number of ball in the bag, that is equal to 8. So 3 by 8. So 3 by 8 is the probability of getting a red ball. Okay, the next question is, what is the probability of getting a not red ball? Not red ball. So It's 1 minus 3 by 8. Not red ball, it's 1 minus probability of getting a red ball. 1 minus 3 by 8. So that is 8 is the LCM. 8 minus 3, that is 5 by 8. So probability of not getting a red ball is equal to 5 by 8. Completed. Okay, now tell me, any problem from your side? Anyone? If you have any problem, you can tell me. Otherwise, we will move to the next question. No, sir. Okay, let's move to the next question. The next question is question number 9. Question number 9. Question number 9 is, a box contain 5 red marbles, 8 white marbles and 4 green marbles. One marble is taken out of the box at random. What is the probability that the marbles taken out will be red, white and not green? Okay, so this is the bag, and 3 type of marbles are there. 5 red marbles, 5 red marbles and 8 white marbles and 4 green marbles. Okay, so let's write the data given here. So given number of red marbles is equal to 8. The number of red marbles is equal to 8. Number of white marbles is equal to, red marble is 5, number of white marble is equal to 8, and number of green marble is equal to 4. So first find what is the total number of marble. Total number of marbles. So it is 8 plus 5 plus 4. 8 plus 5 plus 4. That is equal to 17. Total number of marble is equal to 17. Now, the first question. Probability of red marbles. Red marbles is equal to, so the formula is favorable number of outcome by total number of outcome. Favorable number of outcome by total number of outcome. Now put the value. How many red marbles are there? There are 5 red marbles. So favorable outcome is 5 and total number of outcome is 17. So 5 by 17 is the required probability. First question is solved. The second question is white marbles. So probability of white marbles. Apply the same formula, favorable number of outcome by total number of outcome. So how many white marbles are here? There are 8 white marbles. So 8 and total number of marbles is 17. So 8 by 17 is the probability corresponding to the event white marbles. And the third is not a green marbles. So we have 2 procedure here to finding the probability of getting non-green marbles. You can first calculate the probability of green marbles and subtract the number from 1, you get the answer. Otherwise, from the box or from the data, find out the number of non-green marbles, that is equal to 5 plus 8 divided by total number of marbles. So probability of not green marbles Same formula, favorable number of outcome by total number of outcome. So here the favorable number of outcome means the number of marbles which is not in green, so that is 5 plus 8 divided by total number of element is 17. So 8 plus 5, that is 13 by 17 is the probability. Yeah, you can write 17 minus 4 also, Srijan. You can write 17 minus 4. No problem in that. Okay, question is completed. Now tell me, any problem from your side? No. Okay. Rubbing the board. Okay. And now the next question is question number 10, and that will be the last question for today. Question number 10 is, a piggy bank contain 150 paisa coin, 51 rupees coin, and 22 rupees coin, and 10 5 rupees coin. If it is equally likely that one's coins will be fall out when the bank is turned upside down, what is the probability that the coin will be, first question is a 50 paisa coin, and the second question will be will not be a 5 rupees coin. Okay, so we have a piggy bank here like this, and within the piggy bank there are 150 rupees coin, 50 paisa coin. So 50 paisa coins, 100 piece. Okay, 1 rupees coin is 50, and 2 rupees coins, 2 rupees coin is 22 rupees coin are there, and 10 5 rupees coin, 10. Okay, now write the data. So 50 paisa coin, it is question number 10. So number of 50 paisa coin is equal to 100. A number of 1 rupee coin is equal to 50. Number of 2 rupee coin is equal to 20, and number of 5 rupee coin is equal to 10. Now find the total number of coin. Total number of coin. Add them. So total number of coin is 180. Yes, total number of coin is 180. 180. Now the first question is, it will be 50 paisa coin. So probability of 50 paisa coin. Write the formula, favorable outcome, favorable number of outcome by total number of outcome. Okay, what is the favorable number of outcome corresponding to the event 50 paisa coin? Look, there are 150 paisa coin. So favorable number of outcome is 100 divided by total number of outcome is 180. 180. So 2 5s are 10, 2 9s are 18. So that is 5 by 9. Okay, first question is, and will not be a 5 rupee coin. So this is the first question, and the second question is probability of not 5 rupee coin. Same formula will apply, that the favorable number of outcome divided by total number of outcome. Now you tell me, what is the favorable number of outcome corresponding to not 5 rupees coin? The coin will not be a 5 rupees coin. Okay, so look, there are only 10 5 rupees coin out of 180 coins. So favorable outcome means the coin will not be a 5 rupees coin. It's 180 minus 10, that is equal to 170 divided by 180. So that is equal to 17 by 18. 17 by 18 is the required answer. Okay, any problem? Any problem? If you have any confusion, anything you want to ask me, you can. No problem. Okay, very good. Okay, so in my next class we'll solve few more problem, and we'll discuss the different type of cards. Okay, I think you know there are 4 type of cards: hard, heart, spade, club and diamond. Okay, we'll discuss the details, everything in details about the card in our next class. Okay, so up to next class, bye then. And don't leave now, I have to take your attendance.